class. We're about to start section 4.1, A Likely Story. Our learning objectives is to understand key terminology in the study of probability, to compute and interpret theoretical and empirical probabilities, and to compare theoretical and empirical probabilities. Now, as you all recall, today is the day that you are required to do the 3-6 check assignment. But also 4.1 will be available today as well, but it's technically not due until tomorrow. So I will have that available to you, and this video will cover section 4.1. So if we look at and we're on page 299. If you look at the bottom of the page here, it says, in this lesson, we'll examine the basic concepts involved in studying probability. In short, the probability of something occurring is a number that represents how likely it is to occur. You could think of it as the percent change of something happening. The major difference between percent chance and probability is that we write probability as a number between 0 and 1. So in that regard, it's like percent chance with the percentage written in decimal or fractional form. Okay, we come down here to problem number 1. It says a forecaster said that there is a 70% chance of rain today. What is the probability of rain? So if we look at it, rain, 70% is really 70 over 100. Okay, now, if we simplify this would give us 7/10 or 0.7. So that is the probability of rain. And you can see that here also in the Desmos calculator. You could do 70 divided by 100, and that'll give you 0.7. Or if you hit this symbol here with the fraction, it will give you the fractional answer. So that is the probability of it raining. So now we'll move on to the next page. Okay, now we come to what is called sample spaces. Sample spaces, processes such as flipping a coin, rolling a die, or drawing a card from a deck are called probability experiments. A probability experiment is a process that leads to well-defined results called outcomes. An outcome is the result of a single trial of a probability experiment. Some examples of a trial are flipping a coin once, rolling a single die, and drawing one card from a deck. All right. Now it says when a coin is tossed, there are blank possible outcomes. List them. There are 2 possible outcomes, and the 2 outcomes are heads or tails. Those are the 2 possible outcomes. Okay, now, when rolling a single die, there are blank possible outcomes. List them. There are 6, and the possible outcomes are 1, 2, 3, 4, 5, and 6. Now, just to rewrite heads and tails as far as outcomes are concerned, it should be the word heads, comma, tails. Okay, now, in a probability experiment, we can predict what outcomes are possible, but we can't predict with certainty which one will occur. We say that the outcomes occur at random. In any experiment, the set of all possible outcomes is called the sample space. What you did in questions 2 and 3 was find the sample space for 2 different probability experiments. For each experiment described below, write the sample space. The first is filled in for you as a reminder that a sample space is a set, and we write sets inside braces with commas separating the elements. Okay, flip one coin, we had heads or tails. Roll one die, we wrote it out here as 1, 2, 3, 4, 5, 6, but we have to put it in a brace. So so it would be a sample space. Answer a true-false question. You have true, you have false, and we put in a brace. Flip two coins. Now, when you flip two coins, you could possibly get two heads, a head and a tail first and a head second, or you could get two tails. So those are all the possible outcomes. Now, in finding probabilities, it's sometimes necessary to consider several outcomes of a probability experiment. For example, when a die is rolled, we may want to consider obtaining an odd number. There are blank outcomes that satisfy this criterion. List them. Now, if we look back up here, the odd numbers with rolling a die are 1, 3, and 5. There's only 3 of them. So it's 3 outcomes. And they ask us to list them, which would be 1, 3, and 5. Getting an odd number when rolling a die is an example of an event. An event is any subset of the sample space for a probability experiment. This means that an event could be a single outcome or a set of several outcomes. Now we come here to the back. It says, there's a subtle distinction between an outcome and an event. An outcome is a single occurrence, while an event can contain a number of outcomes. So rolling 2 with a single die is an outcome, but can also be considered an event. Rolling an odd number, on the other hand, is an event made up of 3 outcomes, but is not itself an outcome. Let's look at the distinction more closely. You already listed out the sample space for flipping 2 coins. Look back at the table on the previous page and make sure that you have 4 outcomes in your sample space, which we do. It says how many results match getting heads on the first flip and tails on the second. If you look back here, getting heads on the first and tails on the second, it would be 1. Now you could write the number 1. Oh, I wrote it for number 7. You could write the number 1, or you could write out the word 1. It says how many results match getting 1 head and 1 tail. So they just said 1 head and 1 tail is 2 of them, because they didn't say it had to be a specific order. So it'd be 2. Now, it also have here how many results match getting heads on the first flip and tails on the second. So it's 1, so that made that an outcome. How many results match getting 1 head and 1 tail is 2. That's an event. Okay, now identify each scenario in questions 8 to 10 as an event, an outcome, or both. When rolling 2 dice, getting 3 on the first die and 5 on the second. This is considered to be an outcome. And it's also an event. Now we could just write the word both, but I just like to write this out. It's an outcome and an event. When rolling 2 dice, getting a total of 10. Now, this is an event. And the reason being is you have more than one way to get 10 when rolling die. You could do a 4 and a 6. You could do a 5 and a 5. You can also do a 6 and a 4. So it's an event. When flipping a coin 10 times consecutively, getting tails 8 times. This is an event. And the reason being is you could get this various ways of getting tails 8 times. You could get the first 8 flips are tails. So that's one way it could happen. Or you could say the last 8 flips are tails. And or any other combination. do to get 8 tails, because they didn't say that you had to get 8 tails in a row. So you could have got a tails the first 2 and then the last 6 and so on. So okay. Now we move on to the next page. Now on this page, it says here theoretical probability. It says now we're ready to specifically define what is meant by probability. The first type we'll study is called theoretical probability. The goal is to determine all of the possible outcomes in a sample space and determine the probability or likelihood of an event occurring without actually performing experiments. There is one key assumption we make in theoretical probability, that every outcome in a sample space is equally likely. For example, when a single die is rolled, we assume that each number is equally likely to come up. When a card is chosen from a deck of 52 cards, we assume that each card has the same probability of being drawn. You'd have to be awfully bored to flip a coin 100 times, but if you did, about how many times do you think it would land tail side up? I would say half the time, so about 50. Now I could go into explanation by saying that because there's only 2 outcomes, and if it's a fair coin, both outcomes have an equal chance of occurring. In theory, it should be 50-50. Okay, number 12. What percentage of the time would you expect the coin to land tails up? It'll be 50%. Write a fraction with the number of flips in the denominator and the number of times you're expecting it to land tails up in the numerator. What does this have to do with the answer to question 12? Okay, so the amount of times it's flipped is 100. 50 is what we're expecting. And it says, what does this have to do with the answer to question 12? 50 over 100 is 50%. So it is the fractional form of number 12. It's the fractional form of number 12. Okay, congratulations. You just computed your first theoretical probability. You didn't actually flip a coin 100 times. You just used reasoning ability to decide what the likelihood of getting tails is. That's what makes it a theoretical probability. You develop a theory by thinking, as opposed to gathering data experimentally. We'll go to that in a bit. Calculating a theoretical probability. The probability of an event E in a sample space S occurring is given by probability of the event. This E stands for the event, the number of outcomes in the event, the number of outcomes in the sample space. Now, for questions 14 through 16, a single 6-sided die is rolled. Find the probability of each event. If you need to, look back at your sample space on page 300 for reference. Okay, so basically they're asking us to go through this process that we just learned. So we're going to go through that. It says roll in a 2. Now remember, we list how many sides it is to the die. It's 6. Okay. Now how many chances can we get a 2? If we look back on page 300, 2 only appears once. So that would be 1 out of 6. And that's basically it. Now we come here to the back. It says rolling a number less than 5. Okay. So if we look back here, all the numbers less than 5 is 4 of them. So that would be 4 out of 6. And we can use our Desmos calculators if we have problem simplifying. Hold on, let me, guess I didn't type that good. So it'd be 4 over 6. Then we can hit this button here, and it'll give us 2/3. Now it says rolling an odd number. Now remember, the odd numbers on the die was 1, 3, and 5, so it's 3 of them. So it's 3 out of 6, which we know is 1/2. Now, for 17, if 3 coins are flipped, write the sample space. Remember that tails, heads, heads is a different outcome than heads, heads, tails, even though both result in 1 tail and 2 heads. All right, so we're going to go through this. We know that we could get 3 heads. We know we could get two heads and a tail. We can get a head, tail, head, and then we can get a tail, head, head. Then we can go head, tail, tail. Then we can go tail, head, tail. 2 tails and a head. And then finally, all tails. So if we look here, this is 8 different outcomes that we could get. Now it says for questions 18 through 20, 3 coins are flipped. Find the probability of each event. It says 2 tails. So if we get 2 tails, we only have 1, 2, 3 times that we only get 2 tails. So that'll be 3 out of 8. Now it says at least 1 tail. That means 1 tail or higher. So we got 1, 2, 3, 4, 5, 6, 7. So that'll be 7 out of 8. And then it said at most 1 tail. So it could only be 1 tail or no tails. So it's 1, 2, 3, 4. So that would give us 4 out of 8, which is 1/2. Now, we move on to the next page. Now, with our next page here, it says, now that we know a little bit about probability, we can make a series of simple but important observations. Now, observation 1, it says probability is never negative. Explain why probability can't be negative. An event cannot have a negative number of possible outcomes. It can have 0 at the lowest, but not negative. Okay, it says probability is never greater than 1. Explain why probabilities are never greater than 1. An event cannot happen more than the total possibilities. Just like rolling a 6-sided die or rolling a die. There's only 6 outcomes. So the most that you could get is 6 different type of outcomes. That's it. So it'd be 6 over 6, which would give us 1. Okay, now it says when an event can't possibly occur, its probability is 0. When the event is certain to occur, its probability is 1. Explain why impossible events have probability 0 and certain events have probability 1. Impossible events are 0 because they cannot occur. guaranteed to happen. So all possible outcomes will occur. Okay, now we go to the back here, and this is actually our last part of this assignment. It says, explain why the probabilities of all outcomes have to add up to 1. Thinking of rolling a die might be helpful. All outcomes would account for all possibilities so 100% chance or 1. And that is basically it from section 4.1. Now, one other thing that I don't believe that I stated that needs to be stated is that when you're dealing with probabilities, probabilities are written as fractions. They're not written as percentages. So that is something that you need to bear in mind as well. So remember, I will be sending you out an email with the link to the video so that you all will be able to do 4.1. You will be able to do 4.1 today, but you will have until tomorrow to get it done. Today, 3.6 is due as far as the check assignments are concerned. And I also will be resending you the email concerning the final. And I do need to hear from you all by, I believe I put by Monday of next week about the final exam. So I want you all to have a wonderful day, and I will see you or hear from you tomorrow.